Levers are devices that are used to help move heavy loads. For example, a crowbar, which is used to remove nails that are stuck and overcome resistive forces. When using a crowbar, there's a large load at one end, and then a small force can be applied at the other. A wheelbarrow is another good example of a lever, and it's used to lift heavy loads. The wheelbarrow has a large load in the basket and then a pivot point at the wheel, so a small force can be applied at the handles. So levers are used to overcome heavy loads with small forces. You don't need to recall these exact uses of levers during your exams, but you might be asked to explain how the design of similar devices use moments. So how exactly can we move these loads with such small forces? Well, levers work by transferring a moment to turn a small force at one end to a large force at the other end. A moment is the turning effect of a force, and it's equal to the force applied multiplied by the perpendicular distance. Consider a simple lever with a pivot close to one end. We can apply a small force to the far end of the lever, and this force will have a clockwise moment around the pivot. The same moment will be experienced at the other end of the lever, and this is because the whole lever is trying to rotate as one. But the shorter distance from the pivot means that the force from the moment will change. The force at the other end due to the lever will be very large in order to match the moment. Let's have a look at an example. May is trying to move some debris on a construction site. To do so, she uses a steel lever with one end under the debris, 0.2 meters from its pivot. She then applies a force to the other end of the lever, 1.2 meters from its pivot. Given that she needs to supply a force of at least 720 newtons to the debris, calculate the force she has to supply to the lever. So this is a really common use of levers. So for step 1, let's sketch the lever and the forces involved. So the distance from the pivot to the debris is 0.2 meters. And then there is 1.2 meters from the pivot to the other end of the lever, where the force is supplied. The force required to move the debris at the other end is 720 newtons. For step 2, let's calculate the moment needed to be supplied to the debris. So the moment is equal to the force multiplied by the perpendicular distance. So the moment in this example is equal to 720 newtons multiplied by 0.2 meters. So the moment is 144 newton meters. For step 3, we need to deduce the moment May needs to supply at the other end. So we know that the moment is the same at both ends. So the moment supplied is the same as we've just calculated, and that's 144 newton meters. Then for step 4, we need to rearrange the moment equation to make force the subject. And we can do that by dividing both sides of the equation by the perpendicular distance. The equation then becomes moment divided by perpendicular distance is equal to the force. Then in the final step, we need to substitute the values to calculate the force. Now here we've simply flipped the equation we found in the previous step. So the force is equal to 144 newton meters divided by 1.2 meters. So the force supplied is 120 newtons.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!